Okay, so this is a video talking about 3 of the questions from the homework on April 13th. 2 of the 3 had the same mistake, but for 2 different problems. And because I can see which answer everybody chose, I can see that you pretty much choosing either the right answer or the very common wrong answer. So that's actually the first one and the last one we'll do, and then the middle one's a different error that occurred that we'll talk through. Each of these will only take probably 2 minutes maybe to talk through, but I think it'll help shed some light on kind of what's happening. So we've got question number 4 was a tank has 50 liters of oil. So I'm going to just circle that, 50 liters of oil. I'm going to write 50 up here at 4 hours. So that's what we're starting with. And that actually is the issue. So that was the thing that caused the common misconception. Oil's getting pumped in at this particular rate over this particular time using the values in the table. Come up with a Riemann sum estimate using 3 subintervals and how much oil is in the tank. Pretty much to a person, you knew you needed to integrate or add up rectangles, because here we can't actually integrate. We don't have a function. And to do that, we have uneven subintervals. So the first from 4 to 7, so from 4 to 7, we've got a width of 3. From 7 to 12, we have a width of 5. And from 12 to 15, we have a width of 3. And we need to incorporate those different widths. And again, based on the answers you put, I can tell that you did that, which is awesome. So let's see, we're using a right Riemann. So that means we're going to use 6.2. That's going to match with the 3. We're then going to use 5.9. That's going to match with the width of 5. And we're going to use 5.6, which would match with the width of 3. Adding these 3 things up will get us our right Riemann estimate. So this first one's going to be 18.6. The second one, let's see, that would be 29.5. And this third one would be 16.8. And then we need to add these values together. So let's see if we do that. 29 and 16 would be 39, 45, plus 18 would be 55 and 63. Then we'd have 64.9. So I get 64.9 liters, which is the common incorrect answer. So the 2 options of the 5 that you chose were either 64.9, which is wrong as a final answer, or the correct answer is you need to add the starting amount to it. And that got you 114.9 rather, liters. And that is the correct answer. So what that 64.9 is the amount you gained. So that's the amount you picked up from 4 to 15. And then you have to add in the initial starting amount. That's a really, really, really common AP question, and it's a common error that's embedded within the AP problems and the way they use summations. So that was one example of that. I'm going to actually jump forward to the question number 9, and then I'll cycle back and do the one that isn't like this. Question 9, almost identical. The only difference is they're asking you to do a left Riemann sum, and they gave you equivalent lengths. So the width on these are all 2. So it actually makes it a bit easier. 2, and then we're going to add up the 5, the 2, and the 8 for our 3 heights. So we get 2 times, let's see, that would be 2 times 15, which would be 30. And again, the answer isn't 30, but it's the common incorrect answer that people choose, and that many of you did choose. And then the other answer, the correct answer, is you need to take the fact that you're starting with an 11 foot per second velocity. And so you have to add the initial to it, and that gets you to the final answer of 41 feet per second, so 41 feet per second. So exact same type of question, just given in a different context and with a different table, left Riemann sum versus right type of deal, but the overall mistake thread was the same on those 2. So hopefully that helps shed some light on it. And then the third one from the homework that we saw people miss, or I saw people miss, was actually one where there really wasn't any work to do. It was being able to analyze the picture, I guess. So this is number 6 on the homework. And it says, I had to make it kind of small so it would all fit on one screen, but the trapezoidal sum approximates 0 to 4f of x dx, and a right Riemann sum under approximates. Which of the following is a graph? So even if you're unsure what to do on this one, I would start with the thing that's probably easier to judge, which is the right Riemann sum. A right Riemann sum, when you draw that in, let's just do like a a parabola. If you draw in a right Riemann sum, say we just take two subintervals, and we shade that in, and we do another one here, that's an overestimate just by drawing in the rectangles. And the reason that's an overestimate is the function's increasing. So for a right Riemann sum to under-approximate, the function has to be decreasing or going down. So just for this part of it, the right Riemann sum being an under-approximate, you get down to, here's a decreasing function, so it could be true for A, and then here's a decreasing function, so it could be true for C. And then that's it. You automatically are able to toss out B, D, and E because they're all increasing functions, and much like our parabola, you would get an overestimate. So now you're down to a 50-50 shot, even if you're not sure what to do with that trapezoidal information, which our answers were split between A and C. So you knew that. So now it's coming up with, okay, how do I figure out what the trapezoidal sum is? And this actually gets at the heart of what a trapezoidal sum is. So a trapezoidal sum is the average of the left and the right. So you do a left edge and a right edge, and you divide by 2, which means for the trapezoidal sum to be an over-approximate, we know this is under. We just showed that. That means, and if we have a decreasing function, our left is over. For the trapezoidal to be an over, the overestimate for the left has to be bigger. So you have to have more overhang on the left, and this one has to be smaller. So that part of the trapezoidal sum has to be the bigger piece for the trapezoidal sum to be an over-approximate. And you would need to do this kind of abstract thinking to be able to solve this one because they didn't give you a function. So if you think about, well, okay, now what do I do with that? Think about drawing in a rectangle. So if we were to draw rectangles in on these, let's say we go from 0 to 1 on this thing. So we're going to go from 0 to 1, and we're just going to look at that rectangle. If we do a right edge, we're going to draw up from 1 and over, and that leaves us with a fair amount of underhang, I guess. The opposite of overhang, I'm not sure, but basically a fair amount of missed space right here. And I'll grab a different color. But then if we do a left edge estimate from 3 and down, you can see we actually end up with more space up above. So more of an overhang than we had on the underhang. The way I know that is if those two were equal, you would have a diagonal line connecting the two corners. So you'd have a diagonal line from here to here. If we're splitting that excess rectangle in half, but we're not splitting it in half. We actually are having the line bend backwards, meaning this top piece, this left edge, is larger. And I don't really have any mechanics you can work through on that. You just have to go through that thought process. And if you can see it and understand that, okay, that's what's happening, great. If it helps to draw it in, you can draw it in as well. And you can do the same thing with C to verify that it's not working, but the answer ends up being A. So hopefully that helps in terms of how you make that determination.